I'm in South London at Clippercab and talking to Janos Opperman, co-founder and CEO. Janos, hello.
Hey,
So tell me a little bit about what you're doing here.
right. My name is Janos Opperman, and the big question that we're answering here, or that we're trying to answer, is there's 35 million vehicles in the UK on the road today. What are we going to do with them if we want to decarbonize city centres? Are we going to throw every single car of them away and replace it with a brand new EV, or might there be better solutions? So what we've done essentially is we've developed our own kit to convert these London taxis into all electric vehicles. And the benefits of that are very obviously, it's the greenest possible thing you can do, because you don't have to spend all this carbon to make all these, or expend all this carbon to make all these new chassis if you still have vehicles on the road that have life in them, right? So any vehicle that's got a high enough value is worth looking at for a conversion, or for recharging, or for reloading it for the 21st century and turning them into electric vehicles, right? We happen to have picked one of 5 British icons, which are the London Taxi, the Red London Bus, the Mini, the Land Rover Defender, and of course it's a McLaren type sports car, right? The cars that are iconic for Britain and that people love here. And we've picked one of those. We happen to have picked the black cab as a case study to show our capability.
So this journey started in 2017, 2018.
Yeah.
You were a software engineer, or more a consultant, but you then decided that you wanted to do this. Just tell me a little bit about what was involved in getting this started.
That's right. I was a software engineer for more than 10 years, and I have a bit of a corporate background with SAP and Accenture, and then afterwards, for a long time, I did consulting, initially for advertising, and later for startups. I love writing code, ideally every day, and I saw loads and loads of startups from the inside, from inception to 100 users a month, to 1,000 users a month, to 10,000s and above. And I wanted to get my hands dirty with something physical. I wanted to learn about something new, and I thought automotive would be really, really interesting. So what we did initially was, me and my co-founder, we put some money down and built one of these in his dad's garage. And we built a very bare bones prototype, and we took a video of it and we sent that to Innovate UK, and they were like, yeah, this is great, here's some money. So we won a grant, which we then matched with private funding. And we raised £300,000 to date, and we're now stood in front of one of the 2 vehicles that we've built with this. And we're currently raising money. We're currently raising £1 million to make 20 of these, to launch them in a city centre in the UK, and to progress our R&D and to show that we can do other vehicle types as well.
That's a good segue into the R&D. So tell us a little bit about the journey you've had in developing the.
Yeah.
It's not just it's the inverters, it's the electronics, it's the software. Take us through that.
So, from an engineering standpoint, 300,000 is a lot of money for a startup. 300,000 is absolutely nothing in automotive. So you have to be very, very focused and prioritize with a very narrow view. What can you do? How can you put a vehicle on the road that is safe, and that people want to use, right? So what we've done is system level integration. So we took existing systems wherever we could, and we modified them where we had to, and we invented our own where we had to invent our own, but we didn't invent our own when we didn't have to invent our own. We invented what we needed to invent, and we took what was already there where something was already there that could be repurposed, which is half of the course in automotive. If you open the bonnet of your, say, a Mercedes or something, or a BMW, you will find that the brake system is always done by Bosch, the ABS system. So leave it in. This one, same for this car actually. So we left it untouched. Now, we took batteries. There's 40 kilowatt hours of batteries in here, and we took a drivetrain from a Nissan Leaf that we modified. We took the old circuit board out and we put our own control board in. So we took an existing drivetrain and an existing charger from different vehicles and we combined them to put them into this vehicle, right? We took the existing circuit boards out and put our own circuit boards in where we needed to. Stuff that worked off the shelf, we used off the shelf. Now, what I'm holding in my hand is one of our control modules, happens to be control module number 3, which plugs into the existing engine control unit connectors that we're now repurposing as the connectors for our EV control unit, so to speak. Here's a sample. I think this is a previous iteration of the circuit board that you find in there, and then just behind here is the same unit. It's the same unit again, which actually propelled us around the block just a couple of minutes ago. Now, to make all these systems work together, essentially you're taking all the driver inputs, throttle control, key position, is the brake pedal depressed or not, some of those analog signals, some of them are digital. You take all of these signals in and you then translate them into CAN messages that the inverter and the motor combination can understand to actually propel the vehicle. You translate them into CAN messages to control the onboard AC charger, which is a 7 kilowatt unit. Then if a cable is plugged in at the front to charge the vehicle must be immobilized as a legal requirement, obviously, which all the EVs have. This is all stuff which I've programmed onto the STM32, which is in here. Rapid charging as well. This has got rapid charging capability. And if the viewer, if you know about EVs, or even if you don't, you've got essentially you've got a whole bunch of lithium cells, and it's critical that you do not overcharge them because that might cause a fire, and it's critical that you do not undercharge them. So what we have for that is called a battery management system, which spits out information about all the individual cells, which is temperature, and the individual cell voltages.
Yeah.
Right? So all these cells need to be balanced. If only one of them is out of whack, you need to immediately shut everything down. You mustn't run the heater, you mustn't run the propulsion, you mustn't charge the vehicle, because you risk either damaging the vehicle or setting the vehicle on fire. That's all fine, that's all done by the BMS, and the BMS raises safety flags, and then it's key that the system that's integrating is obeying those commands. And that's essentially what we've done and what we've developed. The interesting thing, I guess, about our approach is that we're not tied to any one supplier. We've developed our own kit so we can take and mix and match components that are there. So this is one of 2 identical vehicles. And the idea is obviously to build more and more of these and invent where we have to, and always have small iterations that bring us back to working system when we're improving the system, right?
Yeah. Now, one of the important parts of this was your involvement or using stuff from inverter.org. So tell us a little bit about that.
So my friend Johannes from Germany launched this community, openinverter.org, and what he's done is EV is such a fast-moving field, right? He wanted to have an EV not that long ago. I think it's like 9 or 8 years ago or something. And the only way he could do it initially was by building his own inverter from scratch, which is something that I wouldn't be qualified for. Well, I may be qualified. I could do it now maybe, but I couldn't do it at the time for sure. Anyway, so he built his own inverter. And once he built it, he realized there might be an easier way to do this. And the easier way to do this is the same approach that I described before. He took something that was already there and figured out a way to modify it by taking his control board out and by taking the existing control board out and putting his own developed control board in, was then able to drive an AC 3-phase motor. All new electric vehicles have 3-phase AC motors because they've got performance and efficiency at low RPMs as well as high RPMs, i.e. even when you go around a car park or if you go on the motorway, they operate at a high level of efficiency, right? So what Johannes has done is he set up this, he invented this way of taking an existing inverter from any manufacturer and turning it into something that everybody can use, right? And he invented and developed this, and then he decided, I'm going to give this away to people who want to use this for their own EV conversions, right? And we're essentially building on top of that as well. So we didn't reinvent the wheel. We didn't reinvent where we didn't have to. We took what he developed for the inverter. We developed our own orchestration that integrates with the taxi as well as the EV drivetrain. That's essentially the story of Open Inverter.
And you've given back to that community as well.
And we've given back to the community. Everything that's taxi specific, we hold on to. Everything that is specific to a individual component, why wouldn't we share it with the community? So we give it back to the community to encourage other people to do this. Because we don't believe that other people converting electric cars are our competition. We believe our competition is climate change and combustion vehicles, right?
Okay. Now, on the electronic side, you said that was another challenge, but you managed to sort of develop the electronics using an STM32,
Yeah.
and you're not using an operating system. So just walk us through that.
Right. So the firmware is bare metal C++ on an STM32. We're using libopencm3. If you're so inclined, you can look it up. It doesn't have. I manage my own memory. There's a scheduler built around some interrupts. The code in here takes in a bunch of analog signals and digital signals from the vehicle and turns them into largely CAN messages and some digital and analog outputs, i.e. for the contactors, or feeding into the brake lights.
Just tell us a little bit about where you have to come to a level where the software is working.
Right. As I said before, I'm a software guy by trade. So what you do in software is you build the MVP, the minimum viable product, and you put that in front of consumers as fast as soon as you can. Take their feedback in, and iterate on it. Right. So the goal here was a similar approach. We said we need to get a working vehicle, as bare bones as it might be, as soon as we can. Put it on the road, drive it around the block, see what's happening, right? There's heating problems that you can have, you might have bad solder joints, all these things, and you only find where your approach is wrong by actually putting miles on these vehicles, right? Which is why we've put more than 10,000 miles on these cars with our own approach, with the mechanical modifications, which I haven't even gotten into, and the custom-built electronics and the custom-built firmware.
And are you the only people doing this? I mean, there's lots of people doing conversions now to electric. I mean, where do you see yourself sort of positioning yourself here?
Right. I think our focus is very, very clearly on British vehicles, i.e. the 5 vehicles that I mentioned earlier. The taxi, the Mini, the Defender, the sports car, and the red London bus. Additionally, we've got to focus on commercial vehicles or on B2B. This is what scales, and this is where you can also have a big ecological impact. If you convert someone's private vehicle and they drive it 2 times a week, the impact is relatively little. If you convert a taxi that's driving 120 miles in a city centre every day, currently in a diesel, they sold these up until 2018 as brand new diesels. That's 5 years ago. So they're going to be polluting a long time unless you do something like this with them, right? So our focus is very clearly on commercial vehicles that scale, where i.e. there's many that need to be converted and that are going to make a high ecological impact.
Janos, thank you very much.
Thank you very much for having me.